Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. We're going to continue on with applying exponent rules. We're going to get to dividing exponents. What happens if you're going to divide one exponent expression by the other? So the rule I have here is when dividing powers, subtract the exponents. Now that's kind of a shortcut, but let me show you why this works. Let's say in our first example we're going to have x to the fourth power divided by x to the second power. Well, if we write it out the long way, we're going to have on the top x times x times x times x. We got 4 of them because of the exponent power there. And on the bottom we have x times x, which is x squared. We can cancel out common factors. So in this case, a pair of x's from the top and the bottom are gone, which will give me x squared on the top and 1 on the bottom. Remember, if everything cancels on the bottom or the top, it's a 1 factor. So my final answer is x squared. But I want you to know that you can also, with like bases here, x and x, you can take the 4 minus the 2. So this is really x to the 4 minus 2 power. Okay? Notice how you would still get x squared. So the act of dividing is actually a subtraction of the powers. All right, now in this one, you're going to see some in our problem set coming up. We have powers of powers that we have to deal with first, and then we're going to use our exponent division rule. Now this negative 4 is on the outside of the parentheses, so it does not change. Okay, it is not being raised to the third power. But inside here we have x to the first y squared, and that'll give us x to the third power y to the sixth power. And on the bottom we will have our x to the fourth y squared. Now when we divide, we're actually just going to compare our powers. We're going to still have the negative 4. And notice how we have x to the third on the top and x to the fourth on the bottom. So it's 3 minus 4, which is x to the negative 1. But if we think about it written out the long way, notice how we would have an extra x on the bottom. So all the x's on the top would be canceled out, and they'll leave us with 1 extra x in the denominator of that fraction. But on the y's here, we have y to the sixth divided by y to the second. Subtract those exponents, will be y to the fourth on the top. So this would be our official answer. All right, so notice how we can subtract the exponents when we're doing division. You think about it as canceling factors. Okay, we're comparing number of x's and y's on the top compared to being on the bottom. All right, let's look at a few problems to try. Here we go, 17 and 18. I want you to simplify those expressions. And we want, when I say that, I want to have an answer with no negative exponents and cancel out any common factors you have and simplify it as much as possible. Go ahead. All right, here are the answers. Now, number 17, how did we get a 1 on the top? And on number 18, how did we get a 2 on the bottom? Let's take a look. Take care of the powers down here in the denominator, and so x squared raised to the fourth power, remember how we multiply exponents? X to the 8th. And y to the third raised to the fourth power would be y to the 12th. And then we have y squared, of course, that's still there. And we have 2y x to the fourth. All right, now probably the easiest next step is to combine this pretty ugly denominator we've got and combine it all together and see what happens. So we still have 2x to the third on the top, And notice how we have a 2 coefficient and no other 2 coefficients there. So let's put the 2 there. And we have x's, x to the 8th and x to the 4th, and that would be x to the 12th. And the y's would be, we have the 12 y's there, another 2 would be 14, and then 15. All right. Factor out a 2 factor from the top and the bottom. And for the x's, I have 3 on the top and 12 on the bottom. And if I subtract, that means I'm going to have 9 left over. So there we go. There's my x to the 9th power represented right there. And I have y to the 15th on the bottom and no y's on the top. And that's why we have y to the 15th there. Notice how I would cancel this out and make it to the 9th power. So that's why everything's gone on top and I have a 1 left over. All right, let's look at number 18. Taking care of the power of the powers on the top, that would be m to the 6th, n to the 9th. Okay, hopefully that's no problem for you. And then I have, let's go ahead and multiply this together here. The 2 is all by itself as a number factor, so put that in the front. And I have m to the 1st, m to the 3rd, so it'd be m to the 4th altogether. Add those exponents together. And I have n to the 4th times n to the 3rd is n to the 7th. All right, now when I do some canceling here, let's see what happens. The 2 is still going to stay down in the bottom, so there we go. Notice how I have m to the 4th and m to the 6th. When I do some canceling there, that's going to leave me with 2 m's left over in the numerator. There's 2 extras left over on the top. So that's this part right here. And comparing my n to the 7th on the bottom to the n to the 9th, remember we subtract there and we get 2. So, just like you see there, m squared n squared over 2. All right, thank you for watching this problem set, and we're going to continue on the next video with a few more examples for you to try. Thanks for watching. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard.